Hello guys, welcome to Study Infinity. Today we will discuss some more questions on matrix algebra. As I said on previous video, I am starting this video series on objective mathematics to help you guys prepare for the competitive examinations. So let's move on. So as I said, objectives of this series will be helpful you guys preparing for the upcoming competitive examinations and to cover all the topics of engineering mathematics in brief, and it will provide you a quick revision of the subject, and you will learn basic things related to the topics. So let's see the questions. So the question is, what is the minor of the element 6 of the determinant, where determinant is given by this 3, -2, 1, 4, 6, 5, 2, -1, 7, and these are the options. So first we will see what do we understand by minor. So for a 2 cross 2 determinant, for example -3, 1, 5, 6, we can say minor of -3 is here 6. So minor of -3 is 6, and minor of 1 is 5. Minor of 1 is 5. Minor of 5 is 1. Minor of 6 is -3. So how do we determine what is the minor of these elements? The definition of minor is the determinant value after deleting ith row and jth column is called minor of the element aij. So if we want to find out the minor of -3, we delete this row and this column, remaining is 6. So determinant value of this value is 6. So we write minor of -3 is 6. Similarly, if we want minor of 5, so if we want minor of 5, we wrote this row, we delete this row, and we delete corresponding to the 5 element column, then remaining will be 1. So we write minor of 5 is 1. So here as you can see, if we want minor of -3, delete first column and first row, delete this column, delete this row and this column, so remaining is 6. So we can say minor of -3 is 6. So let's see for the 3 cross 3 determinant how we determine the minors. So example here 7, 4, -1, 2, 3, 0, 1, -5, 2. So what is the minor of 7? As you can see, the 7 is here. So if you delete this row and this column, remaining part is this much. So we will determine minor by calculating the determinant value. So 3 into 2 6, -5 into 0 0. So the minor of 7 is 6. Similarly, minor of 3, for minor of 3 here 3 is there. So minor of 3, if you delete this column and you delete this row, remaining is 7, 2, 1, -1. If you calculate the determinant, 7 into 2 14, minus of 1 into -1, so minus will be plus, so it is 15. Minor of 3 is 15. Similarly, if we want to calculate the minor of 1, so here 1 is there, so we delete this, we remove this column and we remove this row, so remaining part is this. So we calculate the determinant value of this part, so it will come as 3. So this is how we calculate the minors. So coming to the solution of the questions that was given, so it was asking minor of 6, so here it was 6. So if you delete the rows and columns, remaining part is 3, 7, 2, 1. So if we calculate the determinant, 21 minus 2 equal to 19. So the answer is 19. As you can see here, option A is the answer, correct answer, 19. Let's see the next question. What is the next question? If A is the cofactor matrix of B, if A is the cofactor matrix of B. So B is this matrix, so it is saying A is another matrix which is the cofactor matrix of B. Then A11 plus A21 equal to dash, where A11, A21 and Aij are the elements of A matrix. So A matrix is the cofactor matrix of the given matrix B, and A11, A21 are the elements of A. So it is asking A11 plus A21 equal to how much? So these are the options. Let's see what do we mean by the cofactor. Basically cofactor is minor plus signs. So if we consider the minor with signs, then we can know what is the cofactor. For example, for 2 cross 2 matrix, this is the pattern of the signs, plus minus and minus plus. We have to remember this pattern to calculate the cofactor. So for 2 cross 2 matrix, plus minus minus plus. For 3 cross 3 matrix, or we can say 3 cross 3 determinant, plus minus plus, first row plus minus plus, second row minus plus minus, and third row plus minus plus. The first row is plus minus plus alternatively, and second row is minus plus minus, and third row is plus minus plus. So first we have to calculate the minor, then we have to apply the signs, then you can find out what is the cofactor. For example, if A is minus 3, 1, 5, 6, so minor of A matrix will be, minor matrix of A is 6, 5, 1, minus 3, because let's see for each element. For minus 3 element, what is the minor? So if we delete this column and this row, remaining is 6. So for minus 3 it is written as 6. Similarly for all the elements it is written the minors of the respective elements. So if you combine those elements, we can construct a matrix, and that matrix is called minor matrix of A. Then how can we know what is the cofactor matrix? As we have discussed, cofactor is nothing but minor plus signs. So cofactor A equal to 6 minus 5 minus 1 and minus 3. How? So we have calculated the minor here. If we apply the signs, plus minus minus plus, so 6 with plus 6, 5 with minus minus 5, 1 with minus 1, and minus 3 with plus is minus 3. So this is finally the cofactor matrix of A. This is how we calculate the cofactor. And here is an example of 3 cross 3 matrix. So let's calculate the minor of A first. So for calculating the minor, let's suppose we want to calculate the minor of 7. So we have to delete this row and this column, remaining part is this. So if we calculate the determinant value of this, it will come as 6. So we write 6 for 7. Similarly, we calculate the 4, calculate the minor of 4, minor of minus 1. We can calculate minor of all elements. Then you can arrange them in a matrix form. Then we will get this 3 cross 3 matrix, which is the minor matrix of A. Then if we want to find the cofactor of A, we have to apply the signs. How we will apply the signs? Plus minus plus minus plus minus plus minus plus. See, the minus signs are forming this kind of shape. So you can easily remember, minus signs are in this kind of shape: plus minus plus minus plus minus plus minus plus. So the minus signs are forming this kind of shape. So if we apply those signs with the minor matrix of A, 6 with plus 6, 4 with minus 4, minus 13 with plus minus 13, 3 with minus 3, 15 with plus 15, minus 39 with minus, so minus plus 39, 3 with plus 3, 2 with minus 2, so 13, finally 13 with plus is 13. So this is how you calculate the cofactor of A. Now coming to the solution of the question, where B is given as 3 0 minus 1 2 3 0 0 4 1. So it is saying A is a matrix which is the cofactor matrix of B. So if A is a cofactor matrix of B, you can easily find out what is A. You can easily find out what is A. And A has the elements A11, A12, A13, A21, A22, A23, A31, A32, A33. So it is asking what is A11 plus A21. So if for A11 we delete this row and this column, we can find 3. 3 is the determinant value, and for A21, as you can see here, a negative sign will appear in the cofactor matrix. So A21 negative sign, determinant of this value is minus 4. So finally A11 plus A21 equal to 3 minus 4 equal to minus 1. So here option B is the answer. You can see minus 1 will be A11 plus A21 equal to minus 1. Coming to the next question, if A equal to 2 4 3 2, B equal to minus 2 5 3 4, then find 3A minus B. These are the options. We have to choose the correct matrix, which is 3A minus B. So let's see how can you solve this. So here A is a matrix given, B is a matrix which is given. So 3A will be 3 into every element of A. 3 into every element of A. If A has 4 elements, we have to multiply with every elements of A. Then you can find 3A. So here you can see 3 into 2 4 2 4 3 2 is 6 12 9 6, minus B matrix is minus 2 5 3 4. So finally we get this. Here important point is we have to multiply 3 with every element of A, not that only a single row or a single column, every element of A. Then we get this answer. So the option C is the correct answer. Coming to the next question, question number 9. If A equal to 101 012 004, then find K value if the condition is given 3A determinant equal to K into determinant of A. These are the determinants. Okay, these are the here represents the determinant. So what is K? These are the options. So here given A matrix and here the condition. Let's see how to solve. So as I said, a matrix, when a matrix is given and a multiplication with scalar is given, we have to multiply with each and every elements of that matrix. So 3A, you can calculate here, it will be 3A will be 303 0 3 6 0 0 12 because A is originally 1 0 1 0 1 2 0 0 4. So if we want to find out 3A, we multiply every element with 3. So finally we'll get this matrix. So if you calculate the determinant value, what is the determinant value of 3A? We'll get 108, and A, original matrix A, as a determinant value, if you calculate, it will come as 4. Here it is 4. So it is saying 3A determinant is equal to K into A. So if we put the values 108, 108 minus K into 4, or 108 equal to K into 4, then K equal to 27. So finally we'll get this answer 27. So what is the difference between matrix and determinant form? This is very basic and important also. What is the difference between matrix and determinant form? Matrix we usually represent by square bracket, but determinant we represent by just putting two bars. A matrix represented like this and determinant is represented like this. And a matrix can be of order n cross m. So it can be of 2 cross 1 or 1 cross 3 or 4 cross 4, which is a square matrix, or 4 cross 5, any order, or one simply one element. Here it is a scalar rather than matrix. So a matrix can be of order n cross m, but determinant is always a square form. Determinant cannot be 1 cross 2. Determinant is always 2 cross 2, 4 cross 4, 3 cross 3, like this. So example, here B matrix is a 2 cross 3 matrix, 250 minus 3 minus 379. C is a matrix, here 3 rows are there, so it is a 3 cross 1 matrix. A matrix is 5 10 0 5. This is a 2 cross 2 matrix. So here it is saying determinant B or that B cannot be found as it is not of order n cross n. So if a matrix is given as like this, 2 cross 3, if you want to find out the determinant value, so it is not possible to calculate the determinant, because determinant value should be calculated of a square matrix. The orders should be like this: 2 cross 2, 4 cross 4, 3 cross 3, like this. So again here C matrix is, if this 3 cross 1, so determinant of C cannot be found, but determinant A can be found because it is a 2 cross 2 matrix, so it can be found, and determinant value is, as you know, 5 into 5, 25 minus 0 into 10 equal to 25. Again, this is a very important difference between what is the difference between matrix form and determinant form. As you can see, if a scalar is multiplied with a matrix, we have to multiply with each and every elements. So if D is this, 3D equal to each element is multiplied with 3. But in case of determinant form, if you want to multiply a scalar, suppose here 2 is multiplied, we cannot multiply with each and every element. We should multiply either a row or single column, either with a single row or a single column. You can see determinant x is represented as determinant of 2 3 4 5 6 8 6 9 12. So 2x is represented as 4 6 8. See, only this row is multiplied with with the scalar 2, not all the elements. But in case of matrix, it is multiplied with all the elements. Similarly, if you want to find out 1 by 3x, here the last row is divided. This row is divided, and other two rows are remaining as it is. So this is the main difference between the matrix form and determinant form. So coming to the next question, it is a very interesting question. So fx is given is like this: determinant of this x cos e to the power x square sin x square sec x tan x 1 2, then the value of minus pi to pi, it is definite integral f of x dx. So it is saying if f of x is the determinant value of this, then what is the integral value of f of x with limit minus pi by 2 to pi by 2. So these are the options. How do you solve this? Let's see. So you can calculate f of minus x. F of minus x will be x is replaced with minus x. Everywhere x is replaced with minus x. So here minus x cos of minus x e to the power minus x square sin of minus x square. Similarly here sec of minus x tan of minus x and 1 2. So minus x will remain as it is. Cos of minus x will be cos s, because we know that cos of minus theta equal to cos theta. Similarly sec of minus x sec of minus theta equal to sec theta. So sec of minus x equal to sec x. Sin and tan are similar. Sin of minus theta equal to minus sin theta. Tan of minus theta equal to minus tan theta. So sin of minus x will be minus sin x and tan of minus x will be minus tan x. So these are the things we have to keep in mind. Then now you can take minus 1 common from the first column. So here in first column minus can be taken outside because it is in determinant form. It is represented in determinant form. So you can take common from any row, any column to the outside of the determinant. So if we take minus 1 common from the only first column, so this is the remaining part, which looks like f of x. This part looks like f of x. So you can write minus of f of x. So finally it is coming like that: f of minus x equal to minus of f of x. So this is the result we need. We have put x equal x. We have put x minus x in place of x, then we have found that f of minus x equal to minus of f of x. This is the property of odd function. As we know, odd function has a property f of minus x equal to minus of f of x, and even function has a property f of minus x equal to f of x. This is very fundamental property of odd and even function. Now question is asking about the integral, definite integral. What is the integration of f of x dx from the limit minus pi by 2 to pi by 2? So we will see in next chapter where we will discuss more about the definite integral, but for the time we will remember this formula. For definite integral, this is the formula: minus t to t f of x dx equal to 0 if f of x is a odd function. So as you can see, we have found that f of minus x equal to minus f of x here. So odd function, so it is asking about minus pi by 2 to pi by 2. So this property can be applied. So final answer will be 0. So here the D option is correct. So finally we can see what concept did we discuss today. We saw minor, how to find out the minor of a matrix, how to find out the cofactor of the matrix. Cofactor is nothing but minor plus signs, minor with signs. And we saw difference between matrix form and determinant form. One of the important difference is multiplication with scalar multiplication. In matrix we can multiply with each and every element, but in determinant form we cannot multiply with each and every element. We can multiply either with one row or one column. And we solved a numerical objective question on where we saw the definite integral property and what is even and odd function. So this is for today. Hope you guys enjoyed solving MCQ math with me. So see you in next video. Thank you.